right, welcome back. We're going to do 3.5 today, which is equations with absolute value. I apologize again for my voice. It's gotten worse, but I'm feeling a little bit better. So I guess a little trade-off, but let's do it. Sorry that this is what you have to listen to, but here we go. So we're talking about equations with absolute value. And the absolute value is, if you recall, the absolute value of 3 is 3, because on a number line, 3 is 3 units away from 0, right? That's what the absolute value is. It tells you how far away something is from 0. Well, 3 is 3 from 0. But likewise, the absolute value of -3, which would just be over here, is also 3 away. And so the absolute value of -3 is also 3, right? So a lot of people like to think of the absolute value as removing negatives, if there are any, but it tells you simply how far something is away from 0. So if I had an equation with an unknown number in there, the absolute value of, I don't know what it is, but if that absolute value is 3, there's 2 options, right? I just listed them right here. The absolute value of 3 is 3, but the absolute value of -3 is also 3. So if I have the absolute value of, I don't know what number is 3, then I have those 2 possibilities. Either x is 3 or x is -3. All right, sorry. So if I have something a little bit more complicated, let's say I have the absolute value of x plus 1 is equal to whatever, 5, right? Then whatever this number is inside the absolute value, x plus 1 is either 5 or it's -5. So I'm going to break it into those 2 possibilities. Either x plus 1 is equal to 5, or I'll write it this way, x plus 1 is equal to -5. Those are my 2 options. Whatever's in the absolute value is either the 5 or the -5. So I create 2 equations, and then I just solve each of these. And you can, of course, check these. Let's check this one. So if I check x equals 4, then that's plugging 4 in for x and seeing if it's true. Well, 4 plus 1 is 5, and the absolute value of 5 is 5. So that's true. Good. If I want to check x is -6, then I plug -6 in there. So -6 plus 1 in the absolute value should be equal to 5. -6 plus 1 is -5. And that, of course, the absolute value of that is 5. So that's true as well. Right? So that's our 2 solutions. We verified them. They're true. They work. Okay. Now, what if I have something like, say, the absolute value of x plus 1 is equal to 3? Well, I can leave this absolute value just kind of there by itself, and I can isolate the entire absolute value by subtracting 1. Right? This means then that the absolute value is equal to 2, and therefore I get my 2 options. X is either equal to 2 or x is equal to -2. And if I check these, the absolute value of 2 plus 1 should equal 3, but the absolute value of 2 is 2. And so 2 plus 1 is 3. That one checks out. Check -2. Well, that one's pretty easy as well, because the absolute value of -2 is 2. 2 plus 1 is 3. Easy, right? So the idea here was to isolate the absolute value. The absolute value term, right? Whatever it is, that absolute value, you want it by itself. Do everything that you can to get it alone, and then break it up into your two equations. So for example, if I have that, right, I can subtract this 4, but I can't do anything with this -3 in here. This whole expression is just kind of stuck in the absolute value, and you're trying to isolate the entire absolute value expression. I just want that thing, all of that junk by itself. So I subtract 4 to get the absolute value all by itself. And now I can break it into my two equations, right? This becomes x minus 3. That thing that's in the absolute value is either equal to 18 or it's equal to -18. Right? I don't change the x minus 3. It's just that thing that's inside the absolute value is either the positive or the negative of what's on the other side. And then I just solve each one of these. And that's it. And you can check those, plug them back in, make sure that they work, and they should. All right. So if we have inequalities in here, right, let's say that I have the absolute value of x is greater than 3. So what this means is, in language, right, this first part means the distance that x is from 0. Is greater than 3, right? So I don't know what number this is, but I do know that it's further away from 0 than 3 is. So if I look at a number line, it's a terrible number line, but 0, 1, 2, 3, -1, -2, -3, right? What numbers are further from 0 than 3? Well, those that are past 3, right? Not including 3 itself, because it's a strict inequality, so 3 doesn't qualify. But it's those guys, but it's also these guys over here that are farther than 3 in the other direction, right? It's those. Right? So we can look at this as the absolute value of x is greater than 3 is the union of two expressions. This first one would be x is less than -3, describes this. It's an or because it's that union. X is greater than 3, right? So whenever I have the absolute value is greater than something, it turns into a union or an or statement, right? And so we would say this to solve something in this manner. right? This turns into two equations, right? This one on the right here looks basically the same as this, but the absolute values have been removed. That is the first step, is just to write, I'm going to write that one. And so this becomes x plus 3 is greater than 5. Right? Went a little higher than I wanted to. And the other one changes the sign, right? So this 3 becomes -3, but it also changes the inequality. So you change the inequality, you change the sign. That's my other one. It's an or because it's a greater than. And the other expression then is x plus 3 is less than -5, right? That value is either to the right of 5 or it's to the left of -5. And then we just solve each one of these. So I would subtract 3, subtract 3. This is x is greater than 2. Or subtract 3 and subtract 3, and x is less than -8. We can graph these solutions. We can write them in interval notation, right? The graph of this, x is greater than 2 is that way. X is less than -8 is that way. Interval notation would be -infinity up to -8 with a parentheses on the -8 union with more parentheses 2 to infinity. There we go. Okay. So this one here, once again, very much like the equalities, I want to isolate that absolute value. So I'm going to subtract 5 from both sides because I can. It gets rid of that. This leaves me with 2 times the absolute value of x minus 3. This is now greater than 2, and I can divide each side by 2. That gets rid of the factor in front and isolates my x minus 3 in the absolute value. That's greater than 1. Because this is greater than, it's an or statement, so I get these two inequalities out of it. X minus 3 is greater than 1, or x minus 3 is less than -1. And then I just solve. And I have those two. Right? So x is greater than 4. Those guys. X is less than 2. Those guys. Right? The absolute value of x, if it's less than, let's say, whatever, 5, doesn't matter. Those numbers that are magnitude is less than 5, you can read this one similarly as is that the distance that x is from 0 is less than 5. So I can't go further than 5 or further than -5. And so it would be all of those numbers in between. Right? And likewise, if it were less than or equal to 5, then it would be the numbers in between, but also including those endpoints. Okay. So this ends up being an and statement. To describe this graph, I would say that x has to be less than 5 and x has to be greater than -5. Right? It's almost the same thing as what we did before, right? It's like the same, well, this is less than or equal to on this one, greater than or equal to, but we just created these two just like we did before, but because it's a less than or equal to, it creates an and statement. So let's take a look at one of these. Say this. So, and it looks like it'll be a greater than or equal to, and so I've backtracked, but you'll see that it's not in just a minute here. So if I subtract 2 from both sides, this gives me a -3. Absolute value of x minus 3 is greater than or equal to -21. But when I isolate the absolute value by dividing this -3, then I have x minus 3, the absolute value. I have to switch this sign because it's an inequality and I divide it by a negative, and so I get this less than or equal to 7. And so this creates those two inequalities that x minus 3 is less than or equal to 7 and x minus 3 is greater than or equal to -7. And then I solve. And there we have it. If I graph this out, x has to be greater than or equal to -4, but it also has to be less than 10. And so it's a equal to, or it's a less than or equal to, right? It's an inclusive inequality. And so it's all of those numbers between -4 and 10, which is written as -4 to 10 and brackets. That's it. Thank God, because now I'm going to go back into bed and die. If you have questions, shoot me emails. A couple of you sent me, well, I had a question, I think, that was posted in the discussion board. So go take a look at that if you haven't. It might be worth looking at. But if you do have questions, shoot me emails. I'll write up answers to them and put them in the discussion boards. But thank you all, and I will see you next time, whatever that is. I don't know. Tuesday, Monday. I don't know what classes. Yeah, Monday. So have a good one.